Hi guys, and welcome back. So in the last video, what we did is we set up an exec command here, so basically ran a shell command in order to test our pod endpoints to ensure that they are healthy. Now we saw in the previous video how running PowerShell and calling an invoke web request command can take more than a second to run, and that kind of interfered with our liveness probe. However, we could also rely on Kubernetes built-in HTTP-based probe as well. So if we come up here to define a liveness HTTP request, we can actually change the configuration of the liveness probe to use a built-in HttpGet instead of using PowerShell or some other external utility as a shell command to run. So rather than specifying exec, we specify HttpGet, and when we have an HttpGet liveness probe, we then can pass in parameters like the path, the port. We can specify custom HTTP headers as well. Plus, we still get the standard configuration options for probes right down here as well. So for HTTP-based probes, you also can specify the scheme. So if you have internal SSL enabled, then you could specify that you want an HTTPS connection as well. And you could also specify the host here as well. But by default, that's just going to be localhost, of course. So that's going to be the pod IP address. So you don't have to specify the host, but if you do want to, you could, of course, do that. So what we're going to do is basically set up an HTTP-based probe instead of the exec-based probe. So let's go ahead and head over to our shell, and we'll start configuring that. And it looks like our pods from the previous video are pretty healthy here. They've stabilized after a few minutes here. So everything is working fine with our shell-based PowerShell-based probe. But what we're going to do is edit our deployment manifest here. And down here under our liveness probe configuration, I'm just going to wipe out everything here. And we're going to go ahead and configure the HttpGet based probe. So I'll say HttpGet, and then I'll say port is going to be port 80 because that's where our service is listening on here. And then we're also going to specify the path. So the path would be /home because that's the path that we configured in our web application. And we don't need to specify any headers if we don't want to, and we don't need to specify the scheme because it's just going to default to unencrypted HTTP, which is what our endpoint is. We haven't configured any TLS certificates on our web server internally. Of course, we could do that externally on a load balancer or something like that, but we're not going to worry about that for now. And then I'm not going to specify the host because we're just going to be using the local pod's IP address. So that should be enough for our configuration here. Just keeping in mind the general configuration options here, we're going to have a timeout of 1 second. So our web application needs to respond in under 1 second. So just keep that in mind. Also, our period in seconds is by default going to be 10. So we could override that to something less. So let's actually do that. And then also keep in mind the success threshold. And that is going to be the minimum number of consecutive successes for it to be marked as successful. And so that looks like 1 by default. And then our failure threshold here as well. So it has to fail up to 3 times. And so I'm going to bump the period seconds down to 5 again. And I'll just leave the defaults for the other values here for the time being. And if we do find out that we need to increase the timeout seconds, we can do that a little bit later on. So let's go ahead and go down to the liveness probe level and say period seconds. And we'll set that to maybe 3. And I'll save that file, and we'll do a kubectl apply on our manifest here. All right, so that should create a new replica set. Let's do kubectl get replica set. And sure enough, there is one right here that was just created a few seconds ago. And it looks like it's already spun up 3 brand new pods. Let's do a kubectl get pod. And I'm going to inspect one of these pods here just to see if our configuration is correct. We'll do kubectl describe, and we need to make sure we do pod in there as well. And as you can see, it looks like we are getting a failure here. It looks like it's saying connection is refused here. And so it may be happening because we're not giving enough of an initial startup time. So let's just kind of keep tabs on that here. If we don't get any more failures here, then we may not actually hit the failure threshold of 3, and so it may actually run healthy. And so if we wait just a few seconds, I think 9 seconds is enough because we have a period of 3 seconds and we have a threshold failure of 3. So if we multiply that together, that gives us 9 seconds. And it looks like it is still up and running here. So it has not yet killed the container running our web application here. So it looks like in order to fix this one error here, what we probably want to do is add in an initial delay seconds that's a little bit longer than the default. And the default is 0 seconds. So yeah, that's probably pretty likely because PowerShell does take a couple seconds to spin up. So what I'm going to do is come back into our deployment manifest here. We'll add in that initial delay seconds and just say, let's give it maybe 4 seconds to spin up. And we'll go ahead and reapply that. And this time, what we'll hope to see is that we start the web server container, but we should not have any failures because we're giving it 4 seconds to actually spin up. So we should have yet another replica set spun up here. And sure enough, there it is. This is our new one right here. We've got 3 brand new pods. So let's go ahead and get those pods, and then we'll just describe one of them randomly. We'll do kubectl describe pod, paste that in. And now you can see that after about 30 seconds, we have started the web server container, but we don't have any liveness probe failures. And that's because we adjusted that initial delay seconds to give our web server process, regardless of whether that's PowerShell or Java or C# or any language that it could be, we're basically just giving it enough time to spin up, and then we're starting the liveness probe invocations after that initial delay seconds of 4 seconds that we configured. And you can see that right up here in the liveness configuration. We have an initial delay of 4 seconds. We have a timeout of 1 second, so our web server must be responding in less than that period. And then our period of every liveness probe is going to run every 3 seconds. And you can see that 1 success will restore it back to healthy, and our failure threshold is 3. So with that configuration, we can use the built-in HTTP-based probe in order to ensure the health of our application. I hope this has been informative for you, and I'd like to thank you for viewing.